Hi, this is the podcast that runs alongside Handbook 4 that looks at non-parametric two-sample tests. The two-sample non-parametric test in our commander is the Wilcoxon test. This is often used when you've got two groups of data and you want to test if there is a significant difference between them, however your data is not normal. So you can, if you remember from previous podcasts, we've looked at how to test for normality to see if there's a normal distribution in our data. If there's a situation where your data isn't normally distributed, then we can use non-parametric tests. In this example, we're going to use a data set called eggsnumber.csv. You can find this data set in the Science and the Environment undergraduate programs Moodle page. I've saved that to my desktop and we can now import that in. So it's probably best that you do the same thing. Save it to somewhere you can locate quite easily, and then we need to import it into our commander. The first step, let's import the data. Go to Data, Import Data. Our file saved as a comma-separated value file, so that's a text file. So select the top one. I'm going to be consistent and keep the file name similar. So I'm going to call mine egg number, and then ensure that you select comma as the field separator and click OK. It'll let you navigate to wherever it is, so I left mine on my desktop, and there you go, there's egg number there. Click OK. Your data should come out blue. Well, the message down here should be blue if your data was entered correctly, and in this case it looks pretty good. We've got 20 rows and 2 columns. It's always good to check anyway. So view data set. Okay, we got 2 columns. We've got our region, our grouping variable, and we've got eggs, which is our continuous or measured variable. Okay, so we can shut that down. So the first thing you might want to do is, with all your data sets, is explore it. So you may do a numerical summary of it. So if you go to statistics, summaries, numerical summaries, and this will allow us to split the number of eggs between north and south. So if we summarize by group, select region, and then you can change which statistics it produces. We're not so interested in the quantiles here, so we'll get rid of that. And there we go. So this has produced a mean, standard deviation, interquartile range, and sample sizes for each of our regions. So we've got the same sample size for north and south. And now we've got our mean values. So you can see the mean number of eggs in the south is 2.8, and in the north it's 1. So there's a larger number of eggs being laid in the south. But we want to know whether this difference is significant. So we want to apply a statistical test. Now we're going to assume that this data isn't normally distributed, but with your own data you need to test this. But this is count data, and we already know that it's not normally distributed. Okay, so go to non-parametric tests, and it's a two-sample Wilcoxon test that we want to select. This is our non-parametric two-sample test. So we select that. Our 2 variables are already selected. This is our grouping variable, so in this case whether it's north or south, and our response variable is our measured variable. Click OK, and our output is down here. Our output always comes in this bottom screen, and we've got similar outputs as we have with other tests. So we've got our test statistic, or our Wilcoxon rank sum test statistic value, which in this case is 19, and we have a p-value, and we want to see if this value is below 0.05. In this case it is. It's well below 0.05, 0.017. So what we found is there is a significant difference in the average number of eggs laid between the north and south. So we may want to put this in a report. We may write something similar to this. So you may say there was a significant difference was shown between region and number of eggs produced. In this you may put, you will put in brackets the test statistic value and the p-value. You also put your sample size in there as well. So we've got 10 samples from each region, so our sample size is 20. Then you can go on a bit further and say there was a significantly higher mean and median number of eggs produced in the north, and then in brackets again you might put the mean values. So you put the mean of the north there, and the mean of the south, and you put the mean at the median value of the north and the median of the south in there. Just add an extra little bit of information in there. So this is how you'd report it in a paper or a project, but you may also want to represent it graphically as well. And the best way of representing this sort of data is to do a box plot. So if we go to graphs and go down to box plot, first option here allows us to pick our continuous variable or a measured variable, so we'll select X, and we want to see the difference visually between the north and south. So if we want to plot by groups, we select region there and click OK. Is there anything else we want to add on here? You may want to change the X label, so I'm going to call mine region, and we're going to call, so that's our X label along the bottom. Along the Y axis, we're going to put egg number, or number of eggs, and then we'll give it a title as well. So we're going to call this figure 3 eggs and region. It's not a particularly snappy title, but once you're happy with that, you've added the title onto your graph, you can click OK, and there we go. We've got a visual representation of our data, and you can see there does seem to be a lot of difference between north and south, and this is significantly different. Thank you very much.